So today we will discuss DC response of an RL circuit. So consider this circuit consists of the resistance and inductance, right? The inductor in the circuit is initially uncharged and series with the resistor, right? And suppose that when S is closed, switch is closed, so then we can find the complete solution for the current, right? So we will apply KVL. Then we will apply KVL in this circuit, and we find this equation. So this equation the current I is the solution to found, and V is the applied constant voltage, right? Voltage V is applied to the circuit only when S is closed, right? So this equation is the linear differential equation of the first order, and comparing to this non-homogeneous differentiation equation. So this is the non-homogeneous differentiation equation, and solve this equation, right? And C is the arbitrary constant. So we can write the current equation is that this is the current equation, and so determine the value of C. So we will find the value of C, then the T, put the value of T equal to 0 when the S is closed, right? Just before the closing the switch, as the current in the inductor is also the 0. It is clear. The inductor does not allow the sudden change in the current, right, after the switch is closed. Okay. When T equal to 0 in this condition, then I is also 0. If e की power 0 is 1, so I C plus V upon R, then the value of C is V upon R, right? Substituting the value of C, put in this equation, then solve this equation. V upon R minus V upon R, e की power minus R upon LT. Why? So substituting this equation, C is equal to V upon R in this side, right? So two part is there here. V upon R is the steady state part, and V upon R e की power minus R upon L of T is the transient part. This is transient and this is steady state, right? So when S is closed, the response is steady state value after a time interval, right? So this is the V upon R is the steady state, right? And the response of the steady state value after the time interval. This is figure, okay? So what is the transient period is defined as the time taken from the current to reach final and steady state value from initial value. In the transient part of the solution, the quantity of the L upon R is the time required for the current to reach from the initial value of 0 to the final value. 0 to final value, right? V upon R. The time constant function of V upon R E raised to minus L R upon L of t is the time at which the exponent of E is unity, where E is the base of the natural. Right? Where L upon R is the time constant and denoted the tau. Okay. The transient part of the solution I equal to V upon R. This is the transient part of the solution. Right? Expression is that V upon R e ki power R upon L upon R is R upon L is minus tau upon T upon tau. Okay? And one time constant transient term reached 36.8. This is 36.8. One time only. Okay? Of an initial value. And put I equal to 2 tau. V upon R. E की power minus 2. Minus 0.35 V upon R. One time is 0.36.8. And second time उसकी वैल्यू पुट करेंगे. E की पावर माइनस 2. E की पावर रस 2 की वैल्यू क्या होगी उसको चेक करेंगे. राइट. एंड देन नेक्स्ट इज I 3. जैसे यहाँ पे I 3 tau and then the value is 0.498 and I is 5 tau. Then V upon R e की power minus के 5. Then the value is 0.0067 V upon R. Okay. So that the transient part reaches more than 99% of the final value. So we can find out the voltage and power across the each element using the current.